So for my amazing video assignment, I've chosen to do it on the Diels-Alder reaction because I feel like I understood that reaction the most out of everything that was taught. Like, I understood a lot of it fairly well, but I feel like I just grasped onto the Diels-Alder. So the Diels-Alder reaction is a reaction that was named after its two discoverers, Otto Diels and Kurt Alder. And in this reaction, two carbon-carbon bonds are formed. This happens because a diene and a dienophile react with each other. And the way this works is the diene will kind of bond with the dienophile, and these bonds will basically shift and form two new carbon-carbon bonds. And this particular reaction that I'm showing is considered a 4-2 cycloaddition because in the diene, there are 4 electrons that are moving around, and the dienophile has 2 electrons moving around. And then it's a cycloaddition because it then forms a ring. So that's the basic mechanism. By the way, the Z there is just any substituent that could be connected to it. Now, there are some thermodynamic considerations. Any moderate temperature will favor that reaction to form the diene, the Diels-Alder product. However, if the reaction is over 200 degrees Celsius, it will form the retro Diels-Alder, which is basically the reverse, where you get this happening. And the way that this works is, again, at temperatures over 200 degrees Celsius. These things, the electrons, kind of shift around in the opposite form, hence the retro, it's the reverse. And that's how you can undo a thing like that. Just heat it up a bunch. Now, as I said, the Z here can be any, like just about any substituent. So, for example, if you had something like this, the reaction will take place in the same way as shown before, with the bonds just moving like so. And that would form something that looks a bit like this. It's the same thing. And the retro can also still occur. Something to keep in mind is that it does not necessarily have to be a double bond that causes a Diels-Alder. For example, let's change colors here just for fun. We can have something like this. There's still these two double bonds, but we can have something like this. Which will form, again, the reaction mechanism is still the same. But that will go on to form something that looks like this. There will be, instead of a single bond happening right there, it'll just be a double bond, because only one of the bonds is moving. But pretty much, it's the same theory. But yeah, that's the base of a Diels-Alder reaction. Things can get more complicated, and there are other rules that can, occur that can cause more complicated things to happen. But in general, that's what happens.